wonderful learning individuals. It is a pleasure. I thank you so much for pressing the play button. How are you all doing today? I am Johnny, your host with HomeCountry Mathematics. It is so great to have you. Please feel free to stay because learning math is good for your brain. Now, let us learn some maths together, shall we? All right, excellent. It's great to have you. Again, I'm Johnny. We are continuing on with Chapter 1-2, Order of Operations. We've been solving a lot of different various types of algebraic expressions for fun because math is fun. Oh yeah. Let us do some more and continue on. Again, the more you do, the better you're going to get. I highly recommend you grind as many as possible. Keynote, algebra is the foundation for a lot of mathematics that is ahead of you. All right? Get good at algebra, you are going to be so awesome at math. Let's do this. All right. This one's actually not so bad. It's an easy one. You'll see this and you'll go, oh yeah, that's not a problem at all. I do like the way they've written it. They've put it in fraction form, which is great. I like that. All right, easy to solve. I can continue this by going, whoops. I can show my work just for organization. I can go like this as well. Plus 3 cubed, 12, subtract 7. Okay. We'll bring our work down here. I guess we could probably do this. 3 cubed means 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. All right. So we're following BODMAS, PEMDAS rules, and we're getting rid of the exponent. Okay, any type of fraction creates kind of a neighborhood in the sense. We have a neighborhood above and we have a neighborhood below. Okay, that's what the fraction line does. It creates separation. All right, so plus 3 squared we've determined as 27. And we have 12 subtract 7. So really, all we have left, guys and gals, is a numerator over a denominator. And in both cases, they just have simple addition subtraction. That's it. So let us continue. 27 plus 8. What is that? 8 and 7. I know 8 and 8 is 16, so 1 less is 15. Carry the 1, we have 35. So 35 is our numerator. 12 take away 7. 12 is a positive number. It is also greater than 7. My mind is thinking, let me show you. Normally I would have this open, but just bear with me. should be able to find it quickly. All right, here we go. And rotate. And I'll share this with you. It is a quick integer number line grid that I've created. As you can see, we have 0 here, 0 here, 0 is center. All negative numbers, all negative whole numbers, all negative numbers in general. Beginning at 0, they go left. As you can see, they increase as they go left in the negative sense, and they go on infinitely. At 0 to the right, all positive numbers, again, same logic, they increase to the right and infinitely. The more algebra you work with, eventually you're going to get into some numbers that may be also negative numbers. Okay, so I look at these as also as negative numbers. This is a positive, this is a negative. I'm doing negative. I'm going to the left, 7 jumps. I'm still going to be in the positive because 12 is greater than 7. I need at least negative 12 jumps to get to 0. All right. I'll go over some more integer grid if you want in the future. So our answer is 5. And finally, our answer is going to be, because we know 5 times 7 equals 35. We have 35. We have 5. What is the missing number? That is 7. Why do I always do that? I don't know. I feel like I click it and then it's like it's not clicked. All right, there we go. 7 is our answer. Let us continue. All right. We have in brackets 1 plus 6. Again, these are really easy, guys and gals. That's being multiplied by 9. Anytime you see a whole number, in this example, we have a whole number beside a set of parentheses. That immediately tells you, the great master mathematician that you are, that this is multiplication. All right. And divided by 5 squared, subtract 4. All right. Let's work the problem. One plus 6. I'm going to put the 9 here because I can. 1 plus 6 is 7. Again, I can do this because it doesn't matter the order. I could have 9 times 7, or I could have 7 times 9. I'm still going to end up with 63. Right? 9 times 7 is 63. Shall we confirm? Seven, 9, 63. All right. Whoops. I can continue the problem here since I've already said the answer. Again, I can do this sort of thing because this is independent. This is a numerator. This is a denominator. They're independent of each other. Okay? That's what the fractional line does. It creates separation. So I can also write this as 5 squared, subtract 4, 25, subtract 4, bringing the problem down here now. We have 63, 25, take away 4, 21. Now, this is where, again, I highly recommend you have your multiplication and times table memorized. This is a great example to find common numbers. That's why it is recommended you have this memorized so you could find those common numbers quickly. We have 63 and we have 21. Knowing those common numbers, I'm already thinking 7. 7 goes into 21, and 7 also goes into 63. So therefore, I'm going to use 7 as my factoring number. Seven is going to be the number. Again, factoring is taking a singular whole number and turning it into two numbers. That's all I'm doing. 7. What times 7 gives us 63? 9 times 7. What times 7 gives us 21? Whoops. That is 3. I could actually find another number to factor, but that's okay. I'm going to cancel that because we know 7 divided by 7 equals 1. Any number multiplied by 7, my apologies, any number multiplied by 1 is going to be the same number. I'm left with 9 over 3. I could continue. I know the answer. I do know the answer, but I could continue factoring. Common number is 3, right? So, what times 3 gives us 9? That's 3. I don't need to do this extra step, but just to show the work. What times 3 gives us 3? Well, that is 1. Again, I'm factoring still, and I'm left with 3 over 1. And as you all know, that's going to be 3. There's our answer. I believe I have that. Let's see, number 25. And let's go. The answer is 3. Good job, everybody. Okay, that's it for practicing that. Now we're getting into some substitution. Again, it's all really simple. The ones we're doing, they're pretty easy. They've given us some knowns, okay? All right, those knowns are R equals 2, S equals 3. Again, variables, you can choose whichever variables you want to use. And T equals 11. Double check. R equals 2, S equals 3, T equals 11. Our question is R plus 16. Really easy, boys and girls. It's really super simple. So this is substitution. Okay, normally you could have a variable. This could equal U, something, could be anything. Depends on what you're doing. All we need to do is substitute wherever a variable is. So wherever you see an R, you put in a 2. Okay, it's that easy. Bring down your plus sign, 6. Now, anytime you see a whole number beside a variable, again, that is multiply. 6 times t. So I can use parentheses here. What is t? T is 11. Continuing my work. BODMAS, PEMDAS. Now I have a left-hand side and a right-hand side situation because, or a neighborhood, right? Because of this plus sign. It's the last thing we're going to do. So for now, this 2 is just going to hang out and wait. We have to do this first. This is step 2, multiplication. 6 times 11 is going to be 66. And in simple math at this point, 68 is our answer. All right. Let's do one more quickly. Hopefully I didn't mess up anywhere, and we're good. All right, we're going to be using the same knowns. This one is 7 subtract RS. Just going to bring my work down here. Again, neighborhood, we have a subtraction sign. So I have a left-hand side and a right-hand side. Okay? We're going to work on the right-hand side first because what we have here is RS. It's no different than saying 4S. It's no different than saying 4RS. It's 4 times R times S. Which means we have R times S. So wherever we see an R, substitute. R is 2. Because we're multiplying R with S, I can use parentheses. What is S? S is 3. Substitute our 3. Showing my work. 7 subtract. Again, the left-hand side just hanging out waiting because this is subtraction. It's the very last step. 2 times 3 is 6. 7 is a positive number. Again, looking at this quickly, I shouldn't have closed it. I should have kept it open. Let's see if I can find it quickly again. Closing this, rotate, and bring this. So what I mean is, right, if we look at the problem, we have positive 7 and negative 6. And I always think of adding, subtracting like integers. We're at 7 here, which is positive, right? We need 7 jumps just to get to 0. A negative 7 jumps. Anytime you have a negative, you're going left. Anytime you have a positive, you're going right. Make sense? So we only have negative 6 jumps. Therefore, from 7, I'm going 1, 2, 3, 4, 5, 6. We're at 1. Positive 1. Our final answer is 1. This one I could check my work. Let's see. I check marked it before I even looked. And we are correct. How are we doing for time? not too bad, I guess. Let's see. I'm gonna leave you guys and gals, with one problem, and we'll continue it in the next video. Here it is. 2 times t plus, let me just move this over a little bit. I'm thinking I might need some room. 2 multiplied by t plus 3 multiplied by r, close bracket. Again, this is a linear setup in a linear fashion. Not a fan of that, but I'll give you quick tips. Anything in brackets belong together. So essentially all of this is a numerator. Okay, I'm going to give you that tip. I recommend you turn this into fraction form. Not a fan of seeing a division symbol like this. Again, just turn it into fraction form. Numerator over denominator. Good luck on the answer, and we'll see you in the next video. Take care for now. I'm Johnny, and thank you for being here.